Hey guys, Mr. T here, just doing a quick solutions video for the Year 11 General Mathematics practice measurement test. Show it to you how it's done in real time. Lionel estimates he can drive at an average of 100 kilometers an hour. It's 32 kilometers away. He took the trip in 20 minutes. Find Lionel's average speed on this particular trip. So most people are going to do it this way, the rounded method. Speed is equal to distance over time. So 20 minutes in hours is 20 over 60, which is going to be 20 divided by 60, 0.33 to 2 decimal points. So you've lost accuracy at this point. So your speed is going to be the distance, 32, over the time taken, 0.33. Speed is going to be 32 divided by 0.33. If you did the rounding method, you'll get 96.97 kilometers per hour to 2 decimal points. However, some people, every year, some people freak out with the solutions because they did it a more accurate way. I don't care as long as you round and indicate the rounding. So non-rounded method, just to show you, you could do speed is equal to distance, 32 over 20. 32 divided by 20, 1.6. That's going to be 1.6 kilometers per minute. And so if you go 1.6 kilometers per minute, then you're going to go 60 times as far. In an hour, 1.6 times by 60, 96 kilometers an hour. So you get different answers based on your working out, but you're not going to lose any marks as long as you show the rounding level, okay? So I'm going to do red and purple for this question because every year people complain, they whinge about, oh, why isn't it exactly my answer? Because you need to listen and do the rounding. As long as you show the rounding, you'll be fine. So in red, I'm going to do the rounded version. By how many kilometers was Lionel's estimate out? This is the rounded. 100 was the estimate. Take away 96.97. 100, take 96.97, 3.03 kilometers an hour, kilometers per hour out, or non-rounded, 100, take 96 is equal to 4 kilometers an hour out. I'll take both. What was the percentage error in the estimate? Rounded, percentage error equals the absolute error, 3.03, divided by the actual speed, which was 96.97, times that by 100, add a percent sign on the end. That's going to give you 3.03 divided by 96.97 times the answer by 100. Put a percent sign there. So 3.12% to 2 decimal points. Or if you were not rounding, non-rounded, it's going to be percent error equals the absolute of 4 over the exact, which was 96, times that by 100% equals 4 divided by 96 times by 100, 4.17% rounded to 2 decimal points. Okay? In the test and for this practice test, I'll accept either because this one on the left, the red, shows proper rounding to 2 decimal points all the way through. This one I only rounded right at the end here. But you can see those are quite significantly different answers, both right. This one's less accurate because you rounded early, okay? But I haven't done anything different to what I've taught you previously. Okay, that's question 1 done. 2 different ways. Family uses 381 kiloliters of water in 1 year. Calculate the family's water use in liters per week. Well, a kiloliter is 1,000 liters, so 381 kiloliters times by 1,000 is equal to 381,000 liters. 381,000 divided by 52 weeks in a year. 381,000 divided by 52. 7,326.92 liters per week. Water costs $3.36 kiloliters per kiloliter for the first 130, then 3.63 kiloliters thereafter. How much would the water bill be for this particular year? Well, we know that the first, they've used 381, so they're definitely going to use 130 kiloliters, but we need to know the thereafter. So how much was used thereafter? 381, take 130 is equal to 251 kiloliters after. So what are the costs going to be? First 130 kiloliters is going to be 130 times by 3.36. $436.80 after 130 kiloliters is going to be the 251 kiloliters at the higher price, $3.63. 251 times by 3.63, $911.13. So the total for that is 3, 8 and 1, 9, 6 and 1, 7, 3 and 1, 4, 9 and 4, 13, $47.93 for the year. That's page 1 done. Page 2, a camping tent, 2 meters wide, 3 meters long, 1.5 meters high, decorated with diagonal stripes as illustrated. Find the length of each stripe. I don't need to highlight that because I've got the drawing there. So the issue here we have is that the stripes are wonky. They're angled. They are on this rectangle, which has one of the sides that's this purple line that I've just drawn. That purple line is the hypotenuse of this right angled triangle that I've done in purple. So we need to do maths, Pythagoras on that triangle there to work out the length of the hypotenuse, which I'll just label it H. The bottom side is 1 meter. So H squared, oh, not purple. H squared, according to Pythagoras, is going to be one side squared plus the other side squared, because it's 1.5 meters tall. 1 squared plus 1.5 squared is 3.25. So H is going to be the square root of 3.25, which is going to be 1.80 meters rounded to 2 decimal points. Why is that important? 1.80. Well, the stripe here, which I'm going to call S, is the hypotenuse of this right angled triangle, which we just found one of the sides of. The other side is 3. So let's call that stripe S. S squared is going to be 1.8 squared plus the bottom, which was 3 squared, is equal to 1.8 squared plus 3 squared, 12.24. So S is going to be the square root of 12.24. 3.49, nope. 3.498 rounded to 2 decimal points is going to be 3.50 meters to 2 decimal points. Therefore, each stripe is 3.5 meters long. The tent is a very simple design consisting of the two tent poles. Canvas material for the roof. The canvas is 12.49 adds $12.49 per square meter, and the tent poles are $16.50 each. What does the tent cost to produce? So we have 2 rectangles, 2 triangles at the end. We're going to assume that there's no bottom there. Well, let's do it both ways. No bottom. We'll do the no bottom first. So we have 2 triangles on either side to cover that up. Area of triangle is equal to 1/2 base 2 times by height 1.5 equals 2 times 1.5 times that by 1/2 is the same, divided by 2, 1.5 square meters. The rectangle, area of the rectangle is going to be length times by width, 1.8 times by 3. 1.8 times 3, 5.4 meters. Sorry, 5.4 square meters. So if there's no bottom on this tent, it's going to be area total equals 2 lots of 1.5 plus 2 lots of 5.4. So the total area, 2 times 1.5 plus 2 times 5.4, 13.8 square meters. Is the area of canvas. I'm going to put a line there. So what's that going to cost? 13.8 times by $12.49 times $12.49, 172.36, 2 decimal points on canvas, and 2 tent poles, 2 times $16.50, 2 times 16.5, $33 tent poles, 33 plus $172.36, $205.36. No bottom. Assuming no bottom. Why do I keep going to purple here? My solutions are meant to be in red. Let's change the style back to what I intended. So that is assuming no bottom, because every year I've noticed, and it's fair, the question isn't quite clear whether there's a bottom on the tent, so I'm going to do it with the bottom now. So with bottom. The only extra thing I need to do is the rectangle on the bottom, which is 2 by 3. 2 times by 3 is equal to 6 square meters. So the area total now, if we're assuming there's a bottom, is going to be this 13.8 from before, which was the sides and the front and the back, but plus 6. 13.8 plus 6, 19.8 square meters. So now we can jump straight into finding the cost of the canvas. 19.8 times by $12.49 times 12.49, 247.30 to 2 decimal points. Tent poles is going to be the same for canvas, plus $33 tent poles. So what is that going to be? 247 0.3 plus 33. So $280.30 with bottom. Okay. That is second page done. Third page, refer to the diagram below. Irregular shape, so this is going to be a Simpson's rule question. Clearly, using the diagram above and Simpson's rule, find the approximate area of the golf green if the regions are 2.5 meters wide. So just remind myself, 2.5 meters. What do we have? So just to remind you of the formula, the area is the width of the sections over length 0. So that's the edge on the left, plus 4 lots of length 1, plus 2 lots of length 2. The pattern continues. The second to last length is going to be by 4 again, so length n take 1 is going to be to the times by 4, plus the last length ln, which is this, is not going to be multiplied by anything. So how do we translate that to this? A is equal to, it is 2.5 meters wide, 3. Length 0 is a point, so it has no length, plus 4 lots of length 1, which was 6, plus 2 lots of 8, plus 4 lots again of 12, plus 2 lots again of 14, plus this second to last one is 13, which is multiplied by 4, plus the last length, which is 3. So I'm going to leave the 2.5 over 3. You've got 0 plus 4 lots of 6 is 24, plus 16, plus 48, plus 28, plus 4, 52, plus 3. A equals 2.5 over 3. 0 plus 24 plus 16 plus 48 plus 28 plus 52 plus 3. I get 171. Times that by, times it by, in brackets, 2.5 divided by 3. I get 142.5 square meters is the area of the golf green. Simpson's rule question. The above green is to be developed in an area with poor soil quality. So the owner has decided to lay. So he's going to make it, right now it's 2D. They're going to make it 3D with a depth of 12 centimeters. Find the volume in cubic meters of topsoil required. Okay, so as long as we know the area of a shape, its volume is just going to be how deep it is. So I already know the area. I'm just going to times it by the depth. The problem is I want it in cubic meters, but my depth is in centimeters. So 12 divided by 100 is equal to 0.12 meters. So now volume is going to be 142.5 times by 0.12 times by 0.12, 17.1 cubic meters of topsoil. Okay, next question. I think it's page 4 we're up to. A student designed an outdoor chess piece. So that's why you're doing your DI. There's a question like this as well. Student designed an outdoor chess piece to be built below. Find the volume of concrete that would be required to construct the chess piece. Okay, volume of pyramid is equal to 1/3 area of base times by height. That's going to be 1/3 times by the area of the base is 15 times 15. Times that by the height, which is also 15. This side, 15 times 15 times 15. Timesing by the third is the same as dividing by 3. So it's going to be 1125 cubic centimeters. Volume of, let's work our way down. Volume of the top cylinder is pi times by radius squared times by the height. So it's going to be pi times by, the cylinder diameter is 26, so the radius is going to be 13 squared, times by the height, which is 10. Pi times by 13 squared times by 10. We get 5309.29 cubic centimeters. Volume of the rectangular prism is length times width times height. Here, 15 times 15 times 20. 15 times 15 times 20. 4,500 cubic centimeters. The volume of the cylinder. We can see that that cylinder is exactly the same as the top one, so 5309.29 cubic centimeters. So the volume total is going to be, all those added together, what was the first one? 1125 plus 5309.29 plus another 5309.29 plus 4,500. 16243.58 cubic centimeters. That's not the answer to the question though, because we want it in cubic meters. So if you don't remember your flow chart, you can always work it out. The conversion rate, 1 cubic meter is 100 centimeter by 100 centimeter by 100 centimeter cubed, because 1 meter is 100 centimeters. So what is 100 times by itself 3 times? That's 1,000,000 cubic centimeters. So the conversion rate is 1,000,000. If I'm going from small, which is cubic centimeters, to large, cubic meters, I need to divide by 1,000,000. So 16243.58 divided by 1,000,000 equals 16243.58 divided by 1,000,000. 0.01624358 cubic meters. So that is that page done. Find the total surface area of all the shapes that make up the chess piece in square centimeters. So we're finding just the surface area of all these 3D shapes. Our first problem is this. This triangle is what we're trying to find the area of, but it is at an angle. It is angled. The height of a triangle, the height of this triangle is this line here, okay? So we need to use Pythagoras to find that. And the way that we're going to do that is finding the internal triangle that goes to the center of that pyramid, center of the bottom of that pyramid, and then goes out to the edge. So if I drew that inner triangle, what is it going to look like? Let's call this the H that we want to find. How tall is it? It's 15 centimeters tall, but the bottom is only going to be half of the width of the pyramid, which is going to be 7.5. Okay, so H squared is going to be equal to 7.5 squared plus 15 squared equals 7.5 squared plus 15 squared 281.25, so h is going to be the square root of 281.25, which is going to be equal to 16.77 centimeters to 2 dp. I could copy and paste that to my working out down here. So the surface area of the pyramid at the top is going to be 4 triangles, 4 lots of half. The base of the pyramid was 15 times by the height of the triangles, which was 16.77. And then what is the base of the pyramid? It is a square, which is 15 by 15, so plus 15 times 15. So that is going to be, how do we do this? 4 times by another bracket, 0.5, which is a half, times by 15, times by 16.77, and the bracket, and add 15 times 15 to that, and you get 728.1 square centimeters for the pyramid. Surface area of the cylinder is equal to 2 circles, the top and the bottom, so 2 times by pi times by the radius squared, plus the rectangle that wraps around, which is 2 times by pi times by the radius times by the height of the cylinder. So 2 times by pi times by 13 squared plus 2 times by pi times by 13 times by 10. That comes to 1878.67 square centimeters. It didn't indicate rounding here. Surface area of the rectangular prism equals, let's look at this rectangular prism. It's the same all the way around, and then you've got 2 squares at the top and the bottom. So the rectangles all the way around are 15 by 20, so the area of that is going to be 4 sides that are 15 by 20, and then 2 sides, the top and the bottom, that are 15 by 15. Bracket 4 times by 15 times 20 plus 2 times by 15 times 15. You get 1650 square centimeters. Didn't indicate square for that answer there. Square centimeters. Surface area of the bottom cylinder is going to be the same as before, 1878.67 square centimeters. So SA total 1650 plus 1878.67 plus 1878.67 plus 728.1, 6135.44 square centimeters, which is what we wanted it in. Find the exposed surface area of the chest piece. The bottom of the chest piece is not exposed. So what we have found is all the surfaces of this chest piece, but not all of them are exposed. If we look at that diagram, you are going to have this square on the bottom of the pyramid not exposed, and that square also not exposed on the top of the cylinder. You're also going to have another 2 squares, the bottom of the cylinder, top of the rectangular prism, and another square here, another 2 squares here, bottom of the rectangular prism, top of the cylinder, and then also the bottom circle. Those are all the unexposed areas. So unexposed. You've got the pyramid to cylinder is 2 squares that are 15 by 15. Where's my calculator? 2 times 15 times 15, 450 square centimeters. The rectangular prism to cylinders, because the rectangular prism is sandwiched between the 2 cylinders here. So there's going to be 2 squares there, 2 squares there, all the same. So it's going to be 4 squares. 4 squares that are 15 by 15. 4 times 15 times 15, 900 square centimeters. Bottom of the cylinder, bottom of cylinder is going to be pi times by the radius, 13 squared. Pi times by 13 squared, 530.93 square centimeters to 2 decimal points. So in total, that's going to be 450 plus 900 plus 530.93, 1880.93 square centimeters. That is the unexposed areas. So exposed surface area is going to be the total that we found up there, 6135.44, minus the unexposed areas, 1880.93, which is going to equal 6135.44 minus 1880.93, 4254.51 square centimeters exposed surface area. That's that page done. Pretty heavy maths there, but that's what you've been practicing. Sarah owns a cafe and designs a logo for the business, letterhead, which would be at the top of all its menus. So all of that is useless information because there's no numbers there. What we care about is the logo is 8 centimeters wide, has an area of 29.6 square centimeters. She wants to use the logo as a big sticker on the front of the window cafe. The sticker is going to be bigger. What area is the new sticker going to cover in square centimeters? So you're given this formula, KL, new area is equal to K squared times by the old area. And also you're given that K is new measure over old measure. So what we know here is the new measure and the old measure. So K is going to be 120 over 8. K is going to be, where'd my calculator go? 120 divided by 8. K is 15. The scale factor of this enlargement from the from the little logo to the giant sticker is 15. And now we can find the new area. I'll move this. New area equals K, which was 15 squared, times by the old area, which was 29.6. 15 squared times by 29.6, 6660. That's going to be in square centimeters. Is the area of the vinyl sticker. Area of vinyl sticker. Last question, I believe that is. Is it? No, one more after that. Question 7. The actual length of this car is 4.8. Find the scale factor for the diagram. Find the diameter of the tires. This is important because sometimes your printing is weird when we print out the actual test. So I tell you what the measurement is meant to be just in case the printing is weird. So we're using that formula again for K. K is equal to new over old. So the actual length of the car is 4.8 meters, but we need to deal with centimeters. It's going to be 480 centimeters over the drawn length, which is 7 centimeters. So your scale factor, 480 divided by 7, 68.57. 68.57 rounded to 2 decimal points. Scale factor. So that is A. Why am I doing this off to this side? That's literally the answer to the question. A. Actually, I now remember the formula I would give you in this actual topic is the actual overdrawn. Got a little confused because you're using the same formula here, but you're using it in a different scenario. Actually the same thing, but for scale diagrams, you're given K is the actual size over the drawn size. Same answer. B, find the diameter of the tires. So the formula you're given is actual is equal to K times by drawn length. So actual is going to be, the tires are 1 centimeter on the page, but the scale factor is 68.57 times by the drawn length, which is 1. So it's going to be 68.57 centimeters diameter of tires, because you're shown that the diameter is actually 1 centimeter drawn on the page. That's that question done. Question 7. Question 8, which now I do believe is the last question of the practice. Sheets of paper are 2.5 times 10 to the negative 4 meters thick. How many sheets to make a stack of 8 centimeters? Our first problem, they're not in the same units, so let's convert. Firstly, 2.5 times 10 to the negative 4 meters is 0.00025 meters. And then, how many centimeters in a meter? 100. And if I'm converting from large units to small, I multiply. So 0.00025 times 100 is equal to 0.00025 times 100. 0.025 centimeters per page thickness. And I want to stack 8 centimeters high. So if I want to know how many pieces of paper are in there, my whole stack divided up into each individual sheet. 8 divided by 0.025 is going to be 320 sheets of paper for an 8 centimeter stack. Just check, no other questions. So question 8 done. Question 7 done. Question 6 done. Question 5. C, B, A. Question 4 done. Simpson's rule. Question 3 about the tenths with 2 options for part B, depending on whether you decided there was no bottom or with a bottom. Question 2, A and B done. question 1 with 2 options depending on whether you round it or not. So that is the practice test solutions. Hopefully that helps you out. And I'll see you in the next video.